as I have already told you the definition of the flip-flop, so now we will be discussing about a JK master slave flip-flop. Okay, so this is the circuit diagram. Okay, this is the circuit diagram of the JK flip-flop. So how I have written this one is, don't get panicked by just looking into the circuit diagram. So it is very easy to write down. First write down 1, 2, 3, 4, 5, 6, 7, 8. First write down the NAND gates like this. Write down the NAND gates like this. Then, so this particular section, the first four NAND gates will be acting as, so this full part, the first half part will be acting as a master, and the next half part will be acting as a slave. Okay, so this is will be acting as a slave, and this is acting as a master. So now I have to activate the master, means I have to give a positive clock. If I want to activate the slave, means I have to give a negative clock. Okay, so here positive clock and here negative clock. And to implement or to write down the circuit for master, I am using the 3-input NAND gate, and to write down the slave circuit, I am using the 2-input NAND gate. Okay, so just connect like this. Just use the 3-input NAND gates. Here 2 inputs. Okay, here 2 inputs. All are NAND gates. Put a couple. If you are writing only the NAND gates, wrong. So after writing like this, then you have to connect it like this. See here, there are 3 inputs, here 3 inputs, here 3, here 3. Here 2 inputs, here 2, here 2 and here 2. So finally you will be getting the 2 outputs, and that outputs are called as Q as well as Q bar. You cannot use a different terms like L use monthly, Y use monthly, X use monthly. You cannot use that. You have to use our terms called Q as well as Q bar. Okay, and next the inputs are what? J and K. J and K are the inputs. So among these three, one of the input is being fed back to one of the output. See here, so this line is being connected to Q bar, and this particular input is being connected to Q. Very important. Listen properly. Among these 3 inputs, one input is J, and among these 3 inputs, one of the input is K, and one input is being taken from Q bar, that is nothing but an output, that is a feedback loop. So here also one of the input for this second NAND gate is being taken from Q. See, Q is connected to here and Q bar is connected to here. Next 2 inputs, whatever one of the input is left out from here and one more input is left out here now. So both of them are shorted and it is given to clock. So this whole circuit will come into picture, or it will be activated, or it will be enabled, or it will come to the working, or it will become a working circuit only if you are giving the clock. See, that's why I have written a clock pulse here. See, all these things I will be explaining in the 4th module. Clock and all those things I will be explaining in the 4th module. Just in order to explain the design part of the 5th experiment, I am explaining this, because I cannot again shift from the 3rd module to 4th module in order to just explain this particular experiment. See, I have already left some concepts in 1st module, I have already left some concepts in 3rd module, right? So likewise I am just skipping some of the concepts and I am just jumping to some other modules in order to make you understand the experiments. Okay, but again I cannot jump to the 4th module in order to just explain this particular concept. Anyway, we will try to understand here itself. Okay, so if you want to make the whole circuit or whole circuit get activated, then you have to give a clock pulse. So here for these 2 inputs I am giving the clock, and the same clock pulse is also going to the slave. I told that. Put a dotted line here. This is master and this is slave. First 4 NAND gates are master and the next 4 are slave. So as I have already told you, if you want to activate this slave, you have to give a negative pulse. If you want to activate this master flip-flop, then you have to give a positive pulse. So I have already given the positive pulse here in order to activate this. The same thing can be given to the slave also. The same clock pulse, but in a complementary form. So how to get a complementary form? By just connecting one NOT gate. So instead of connecting a NOT gate here, I am using one NAND gate only. All the inputs are being shorted. If you see here. and A. If I am giving to NAND gate, what it will become? A dot A, the whole bar. That is nothing but A bar, right? So if I am shorting this, or if I am giving the same input for the NAND gate, it will be acting as an inverter only. Okay, if all my inputs are shorted, it will be acting as an inverter. You can take one variable like B and B dot, the whole bar is nothing but B bar only. So if all my inputs are shorted, it will be acting as a NOT gate. So the clock is being complemented and it is given here. Will positive birth or negative birth? If I am giving positive clock here you will be getting negative clock. If I am giving negative clock here you will be getting positive clock. Understood? So now you just understand. So one of the inputs are being given as a clock. So here another input is given as a clock bar to this input NAND gate. That is a slave circuit. And again the output of the master is given to here, and again the output is given here, and again this is being connected to this, and this is being connected to this. See, all these things will be understanding a little bit later how the circuit actually got connected. But right now, how to implement this, how to understand the circuit, I am explaining also. Okay. And again this is connected here, this is connected here, and this output to this, and this output to this. Okay. And this is Q and Q bar. Fine. So now I was telling that I will explain the truth table. Fine. So J, K can take either 0 or 1. So when both the J and K are 0 and 0, and if my clock pulse is positive, then what will be our output? So my output will be the output will be what? Q only. If my both the inputs are 0 and 0, my output will be Q only. Andre output again our output 0 is 0. If my output is already 1, it will be holding that state. Okay, it will be holding that state. Okay. For example, if you are standing in a queue. Okay, if you are standing in a queue in order to take something. Okay, and if it is not at all moving, you will be in the same state, right? You will not be either going backward or you will not be going forward, because the queue is stagnant. You will be in the same state. Same here also, if my inputs are 0 and 0, my output will be stagnant, no change. Q will be Q only. What is Q bar? You are getting the two outputs, one is in a complementary form and one more in the non-complementary form. Don't worry about this column. If you have understood this output, the same thing you have to write it in a complementary format. When my inputs are 0, 0, my output is what? Same state, that is Q only. That Q can be either 0 or 1, it is left to the previous state. Okay. So the Q will be Q itself when my inputs are 0, 0. What will be our Q bar? That means complementary format. Q is the Q bar. Right. Next, if my inputs are 0 and 1, my output is 0. If my J is 0 and if my K is 1, whenever the clock is high, my output is 0. When my output is 0, I will call the comment as reset. And obviously Q bar will be 1 because output 0 is Q bar will be 1. Okay. And if my input is 1 and 0, if my J is 1 and if my K is 0, my output is 1. Okay, my output is 1 and obviously Q bar will be 0 and I will write the comment as set. So on what basis I am writing these comments? By just looking this particular column. When my inputs are 1 and 1, my output will be Q bar. So if whatever the example that I have given now, if both the inputs are 0, 0, it will be stagnant. If my both inputs are 1, then what happens? The Q is getting changed to Q bar. Okay, so you will be getting a complementary output. So Q bar will be Q. So just opposite of this. Okay, Q bar will be Q, and that is nothing but toggling. Toggling under 0, 1 0. So Q bar will be Q bar. Understood? All these things we will understand in the fourth module in depth about discussing about flip-flops, latches, and by truth table, all those things. So right now you just understand, if my J and K are 0, 0, my output is Q, and if my J and K are 0, 1, my output is 0, called as reset. If my J and K are 1 and 0, my output is 1. If J and K are 1, 1, my output is the Q bar. Okay, here you will be getting Q bar, here you will be getting Q. Andre Q is 0 is 1 agutte, 1 is 0. Okay, just understand this truth table. So now So now you have to implement this particular circuit in the digital circuit, in the digital kit. Okay, you have to implement it. So how to implement it? Whenever there is a circuit, okay, you have to write down the pin numbers. Otherwise, it is impossible to implement it in the digital circuit kit. So now how many inputs are, how many 3-input NAND gates are used in your circuit? 1, 2, 3, 4, 5. 5 NAND gates are used. But in one IC, how many NAND gates are there? Only 3 are there. So how many ICs are required? You require 2 ICs. Okay? One IC ಅಲ್ಲಿ 3 NAND gates use ಮಾಡ್ಕೊಳ್ತೀರಾ, ಇನ್ನೊಂದು IC ಅಲ್ಲಿ using only 2. Third one will get wasted. ಅಂದ್ರೆ you will not use anything. That's all. So for the first IC you will be using for all 3, and in the second IC you will be using any 2. You can use any 2. Either you will use this yellow and green or yellow and pink or green and pink, anything. Okay. Next. In the slave again, you are using another 2 input 4 NAND gates. So therefore you will be using only 1 IC. Okay. Now we shall start writing the pin numbers. Please help me out. So this is the NAND gate. So first NAND gate, what are the pins? 1, 2 and 13 are the inputs. Okay. 1, 2 and 13 are the inputs. What is the output of the NAND gate? First NAND gate, it is 12. Second NAND gate, 2, 3, 4. Okay. Sorry, 3, 4, 5. 3, 4, 5. 6 is the output of the second NAND gate. Next, I will be using the third NAND gate here. 9, 10, 11. So 9, 10, 11 are the inputs. 8 is the output. 8 is the output. Now I have to use one more NAND gate. I have to use one more IC. Okay. So I will be writing in a different chapters. I can use 1, 2, 13 and 12. So this is the NAND gate that you are using from second IC. Next, 3, 4, 5, 6. Okay. Now coming to this, so it is very easy. 1, 2, 3, 4, 5, 6, 7 we are not using. 8, 9, 10, 11, 12, 13. And you may ask, can I write 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13. So you can write like that also, not an issue. Okay. Have you all understood this? Please take down properly. So this section is called as a master, this is called as a slave. Why it is called master slave? Because so slave will be acting based on the inputs that you are getting, that is being fed from the master. So that's why it's called as a master, this is called as a slave. So always remember, the flip-flop will be holding the 2 stable states, either a 0 or 1, that is a reset or set. Okay. Based on the inputs you can change the data also, that whatever it has got stored. And again the master will be activated whenever you are giving the positive clock, and the slave will get activated whenever you are passing the negative clock. So this is the master slave JK flip-flop. So this whole circuit you have to implement it in the digital kit. It is very easy experiment. You have to just use only 3 ICs. Okay, ಇದು 2 IC ಬೇಕು ಮತ್ತು ಇನ್ನೊಂದು IC ಬೇಕು. 3 ICs ಇದ್ರೆ ಈ experiment ಆಗುತ್ತೆ. So 3 ICs are enough, and again some wires are required. And if you just understand this truth table, this experiment get over. See, almost all the experiments are a little bit easy only, but since this whole concept, electronics concepts are new to you, you may feel difficult. Okay, so I am there for you to explain. Wherever you are not understanding, please message me personally. So at that instant, if I am not able to explain, means at least I will be explaining a little bit later on. Okay, please take these things very clearly. If you have any doubts, you can ask.